Now let's talk about binomial probability distributions. What's binomial? Well, bi means two, and a binomial probability distribution is one that looks at a variable where there's only two outcomes, like a yes or no. You flip a coin, it's heads or tails. They're about equally likely. That's not very interesting, actually. What is interesting is when we say, okay, let's look at what could happen if we flipped a coin 10 times in a row. A binomial probability experiment I do an experiment where there's two outcomes to each trial. I repeat it a fixed number of times. We call that n, the number of trials. The trials are independent. One doesn't affect the other. And the probability of success does not change through the experiment. Now, with binomial, we always call the two outcomes success and failure. Sometimes that's pretty clear. Like if I'm shooting a basketball from the free throw line, I can do this over and over again. I can say, okay, I'm going to do it 20 times. Whether I make it once doesn't affect the probability of me making it the next time. There's only two things that could happen. I make it or I miss it. If I make it, that's success. If I miss, that's failure. Sometimes with a coin flip, we just sort of assign success and failure to be arbitrary. Like, okay, heads is success, tails is failure. It's just language. So, n is the number of trials, x is the number of times we get success, whatever that is, p is the probability of success on any one trial, and q is the probability of failure. For example, let's say I decide to go to the gym and take 20 free throws with a basketball. I know from experience that I usually make about 18% of my shots. I'm not very good at basketball. So, what's our n? N is 20. What's p? P is the probability of success on any one trial. it's best to have p as a decimal. Why? Because we're going to use it. What's q? To find q. .82. Now, you can find the mean and standard deviation for the number of baskets that you make. These are the easiest formulas ever. The mean is n times p. The standard deviation n times p times q, and then take the square root. Let's try that. (20 times 0.18), that's 3.6, right? Make sure, oh dear. When you find the standard deviation, make sure that you use parentheses under that square root. 20 times 0.18 times 0.2, 1.72. .718. Okay, so that's how you find the mean and standard deviation of a binomial probability distribution. What on earth does that mean? Well, it means that if I'm going to take 20 free throws, I'm probably going to make 3 or 4 of them. Those are the most likely outcomes. The standard deviation is a measure of how far from there I can reasonably expect to fall. Remember, you usually don't get more than 2 standard deviations away from the mean. So I might get 5 baskets or even 6, but I'm probably not going to get 10 baskets. Let's try this one more time. So, in a particular town, 32% of people have a dog. If I call 60 people from this town and ask if they have a dog, what is the mean and standard deviation for the number who say yes? In other words, how many yes answers do you expect out of 60? How do we do it? Mu and sigma. So, what's n? Yep, 60. What's p? And what's q? 1 minus p. Q is always 1 minus p. .68. So let's do the math. Remember, parentheses under the square root, or else find the square root last. Let's see what those work out to. $19.2. And the other one, $3.613. Could probably round it to fewer decimal places. So, if we ask 60 residents, do you own a dog? We expect about 19 of them will say yes. And there's a give and take of 4 to 8 each way.